Hello friends, in previous video we saw transformer-less power supply using transformer. Now we will see power supply which is not having any transformer. So for that reason we use combination of the series of capacitor C1 and R1 here. So why this? Because capacitor will allow to pass the AC, okay, and but this will limit the current. And this is resistor, why we are using this? When there is a no power supply, that time capacitor should have part for discharging, and here is the resistor, it will help to discharge. This capacitor, this resistor is not a quarter watt, it is we can use it 1 watt or more than that only, okay. And capacitor is must be X rated capacitor, okay. Because the normal capacitor we cannot use here, you must have the capacitor which is having capacity more than 300 volt, okay, because we having 230 volt at AC. So what is X rated capacitor? Those capacitor which are non-polarized, okay, so you can place by any way, and they will what it will do, it will pass our high voltage AC to low voltage AC, okay. So this is the circuit which is having resistor and capacitor, both are in parallel fashion. Now what next? So here next is, after doing this, what do you guys are thinking? Here we get the low AC because this is working for the transformer. So what next? Next is nothing but the rectification. And simply, what is the rectifier? We are using full bridge rectifier where we are using 4 diode. Which diode these are? These are 1N4007 diodes, okay. Here now our AC, we have AC on a both side, we don't have any ground, so we will connect this here and this will go to the next. So what next? We are using here a resistor. This resistor will again limit the current, and we can say R2, okay. And this is the capacitor, this is electrolytic capacitor you can use, and that is again having a good voltage, we can say 100 volts it should be. And here at the neutral side we have to use one resistor because it should limit the current if it is passing by this way, okay. And yeah, here we have completed the circuit. Now we will use a zener over here. So what this zener will do? This zener will work as a fixed voltage DC IC which we use 78XX, right? Do you remember? So this zener will work as a same, and it is depending what volt you want at output, you have to use the zener of that volt. I'm expecting 12 volts, so zener is having breakdown of 12 volt. That's it. So this is the zener. And at last, for our visual representation, we are using one LED and the resistor which is again of 1K. This is not having any 1 watt or more than that rating. You can use hardly your quarter watt resistor over here. Now what are the values of this resistor? So we can use here, we will use 470K, and that is of 400 volt. So here I'll make the notes like our C1 is 470K and is of 400 volt, okay. So what next? Next is the C2. So where is our C2? This is our C2, and C2 is equal to again 470 microfarad, and that is of volt, we can say 100 volt, okay. Now what's the value of R1? Here C1 will be 2.2 microfarad, sorry, and here R1 is 470 kilo ohm, and it's of 1 or more than 1 watt. R2 will be, this is our R2 which is of 220 ohms, and again it's of 2 watt. R3 will be 1 kilo ohm and it's of 1/4 watt. R4 will be 100 ohm and it's of 2 watt again. Okay, so diode D1, D2, D3 and D4 all are of 1N4007. These are the switching diode, and Zener 1 is equal to 12 volt Zener. Okay, so let's make the circuit on Proteus and see how the simulation will work. As we see the schematic, okay, so we will now open the Proteus. Now you have the black screen because I have given the administrative access, and for that it is making it blank. Okay, so new project I'll create, give the name whichever you want you can give. I'm giving Transformerless power supply simply and clicking next because I just want to go for the schematic, right? So we will process further and just check the path if you want to go with, and yes, just next and finish. Okay, so here you will get the screen. Now just click on a P over there on the left side and choose the components. Now what we want capacitor, right? So what the value of capacitor is? 22k, sorry, 220k, and 220k is what? It's a 22 microfarad. But what important here is we required X rated capacitor. That means voltage of the capacitor should be high, as we discussed this already. So we will now see for the 400 volt capacitor. Here you can choose by any value, okay, and then we will change it because we have option to edit the properties, change the value of capacitor. So we will do that later. Right now just check for it and select anyone whichever you want. To select the component you just need to double click on it, and that's it. Your component will be added in the devices. Here I have selected 220 microfarad because it is in front of me, double clicking on it. Now the next component which I want is the resistor, right? So here the point is we cannot go for the resistor of quarter watt and all. We need a resistor with value which is greater than 1 watt because we are directly connecting it to the AC. So remember, we cannot go with the quarter or 1/4 or 1/8 watt. Okay, so here we need resistor that is of 1 watt, but in a Proteus we are not getting that value. Cheap resistors are the one which are SMD, so we will go with the 2 watt resistors. Okay, but the value whichever require is we will choose from the library because yes, of course we have that. So 2 watt we have selected and clicking on the value of the resistor whichever we want. Okay, so we will select the resistor. First R1 we require is 470 kilo ohms, right? And of course wattage we talk about is a 2 watts we are taking here. I'm just selecting the values because which are available, so there is no need to go and edit it. Okay, so I'm selecting that resistor. Now I'm checking for the resistor that is of R2. So we will select the value of R2 is 220, right? So 220 R means 220 ohms, and of course it's a 2 watts of resistor. Then we will go for the 100 ohms. So 100 R is there. We will select that and double clicking means getting the value. Now we will select one normal generic resistor for current limiting purpose, and that we will connect at the LED side. So it is just to control the current we are giving to LED. Okay, so there is no need to go for 2 watts of resistor. Here we will selecting now the Zener diode. Now we require 12 volt at the output. Whichever volt you require, you just need to add that Zener over here. So what it will do, it will stabilize your voltage. Okay, so DC output we will get here. Now the capacitors also we will select for that. So what this diode we are selecting, this diode is which it's a switching diode, and we use this for rectification purpose. Okay, we have ready-made bridge available also, but this will cost effective, okay, because 4 diodes are not that much costly. Okay, so now we are placing the components. Here C1 I have placed and placing R1 in parallel with C1. Okay, so here I changed the value to 2.2 microfarad because I have by mistake selected with a different value. Okay, now here placing R1 and making it a parallel circuit. Now I'm giving AC. Okay, so that AC I'll give to this point and I'm just keeping it open. Okay, so I'm just double clicking on it and I'm keeping that open as of now. Now we have to use a bridge rectifier over here. How to draw the bridge rectifier, why these diodes are placed in this fashion. If you want to know more about this, just go to my video where I explain the diode. Link will be there in the description box, so just go and check over that. So of course you will get to know why the diodes are placed in this fashion. So I'm just connecting D1 D4, D1 D2, D4 D3 and D2 D3 in the way I shown in a figure, and then I'm just giving AC in between D1 D2. Now we will go for the next, and that is our R2, which is of 220 ohms, 2 watt it is, right? So capacitor we will use. Why the capacitor we are using? To rectify. Okay, so what capacitor will do? Capacitor will pass the AC and make pure DC. So whatever ripple, whatever fluctuation or AC component we are getting after bridge rectification, all the AC component will be ground by the capacitor. So that reason only we are using capacitor. Here I am using a capacitor and placing this capacitor. Now the capacitor, positive terminal of the capacitor is connected towards the DC positive. But what about negative? So here in non-isolated power supply, that means transformer-less power supply, ground is nothing but the line. So we are just placing one resistor over there to limit the current, and we are just connecting other terminal and keeping it open as of now because AC is still about to place. Okay, so now we have diode rectifier circuit, which we will connect like other terminal, that is ground, we will connect. So this is the resistor of R4 it is, and I placed that. It is of 2 watt, 100 ohms is its value. Okay, so let's place one Zener diode here, and please consider the direction. I am explaining that again. So that direction is very important, otherwise Zener will start conducting. We don't want Zener to be conduct, we only want Zener to give us stabilized DC volt. That's it. Okay, so here R3, and I need to change the value to 1K here I am doing currently, and then connecting that R3 to the negative terminal of the Zener. Here I am selecting one LED. So right as of now I am selecting red LED over here. Okay, and placing that. So we have generic LED, but the generic one will not glow and not give you the visual representation. So for that purpose I'm selecting animated one. So animation is mentioned, you need to type red LED over here, or blue or green, and that will give you the animated LED. Okay, so two types are there, you can take any one. These are active LEDs, so they are glow and they will not glow. This will help us to get the visual exactly LED is working or not. So we will connect positive to the 1K and negative of course to the ground. Okay, so here we will change the name and giving it LED, and here blue LED I have selected and connected it back to the ground terminal. So now there is something which is missing, and that is nothing but the connection between the bridge rectification. You can see like we have to do the connections. Okay, so between D4 and D3 we need to connect. So let's now give the AC to the circuit. So here oscilloscope we have selected, and I missed to record that, okay, because this AC which I have taken from the library is not the one which I require. That makes my software to like stop working, or that makes my recording disturbed. So I have selected the one from the generators only, and I gave the name AC, and you can see like I have changed it. I'm giving amplitude to 230 and frequency to 50 hertz, okay, and giving ground here. So in a AC we are giving ground, but in a actual AC there is a no ground, so we will directly connect that to the neutral line, okay. So here we have done with the connection. I have connected oscilloscope to the AC, and we will check it one by one, okay. So let's save everything and start the oscillations, okay. And now once you start simulation, you have the knobs over here by which you can set the values. Okay, so here the AC we are given, we are having, okay, so as A is yellow, B is blue, and C is red, and D is green. So in this fashion we can have yellow AC. So we can now connect another terminal, and that is to blue. So let's start the simulation over here by saving the diagram. So you can see like we are getting the AC, okay, here also, because capacitor and a resistor will step down the AC, will not give you pure DC here, okay. Now stop the simulation and let's connect the point where we need to check like have we get the DC or not, okay. To check that, what we will do here is we will connect the third terminal, third one C, to the rectification part. So here after the bridge, yes, we should have to get the DC, and yes, you can see we are getting pink and red, we can say, and that's a AC. That is a pure AC we are getting. Some ripples are there. This is the yes, you can see the ripples, and by capacitor, small DC component capacitor will filter out, but there are chances like we are getting the values. And now the final one we will connect at the output of Zener. We are saving it, running it, we are getting the same value DC over here, and that is of 12 volt, okay. So this is how the transformerless power supply we design in a I'm showing you simulation because it is hazardous to show it in a home. So I'll try to make that video and show you how exactly practically it will work. Hope you like the video. Do subscribe to my channel, press bell icon, and do comment if you want to know more about electronics. So we will make another videos on the same. So here we have the video that is of transformer, like power supply using transformer. Do check that video also, so you will get to know what exactly and how components are getting reduced, cost of the circuit is reduced. Thank you.